All right, the beard months are over, so there's that. Now I look like y'all, like little kids. No, I don't. All right, well, anyways, number one we said is prime. Okay, we tried to find all the factors. Nothing would divide into 127, or 127 would not divide by any number, so we call that prime. And when it's prime, we just rewrite it, square root of 127, okay? And we said on number 2, it was 2 times 1050. And we don't stop there because we know we can still divide by 2, right? We're not going to be lazy, right? So let's do that. Help me out. What's divided by 2? Oh my goodness, you did it. And by the way, when these break down, you can cross these out. Now, 525, we want to try, if 2 doesn't work, we want to try 3. Does 3 go into 525? Okay, it does actually. What do we get? You know, just got to press the button sometimes, you know. So, 175, and then 175, does 3 go into that? You can try it, but it does not, so then we try 5. 5 times what? 35, and then 35 is 5 again times 7. Now there's different ways to break it down, but doing it this way, all the like factors are right next to each other. So we only have 6 prime factors. 2, 2, 3, 5, 5, 7. Now we're going to do what? Circle our pairs. What do we got pairs of? Pair of 2, pair of shoes. All right, pair of 5s. Of course, tragedy strikes. Now, when I have my radical, what goes outside? The circled stuff, the pairs, right? So 2 and 5 are going to, it's multiplying time. 2 times 5 is 10. And then 3 times 7, those loners are also going to multiply. So 3 times 7 is 21. Okay? All right, and then on the next one, what's unique about this that we see here? Does everyone see there's a number out front? What's the name of that number out front? Starts with a C. Coefficient. We got a coefficient 3. Now, when we break this down, 2 doesn't go into it, but 3 does. 3 times what? We kind of have this already here, right? But yeah, 175, and then 5 times 35, and then 5 times 7. That's kind of the same as part of the last one. Now, I think we talked about this yesterday, but I want to make sure you see it again. 3 does not have a pair with this other 3. Does everyone see the coefficient 3 is not part of the tree? The coefficient 3 is its own thing, okay? That's why I like to circle the coefficient as its own thing outside. And now I look at my tree and see what are my pairs here. What's my... Just 5, right? Tragedy. So what's going to actually multiply outside? The 5 and the 3 that's already outside. So 3 times 5 is 15. And on the inside, my loners, 3 and 7, are going to give me 21. Okay? So, you've got 2 days with 2 objectives and 2 warm-ups, right? Okay? So, yes. Why did I shave my beard? It was time. For laughs. Chuckles. All right. So, we're going to finish those notes. Now, yesterday we were right about on these examples. We did these. Did we finish all 6? Okay, so this was 1 through 4. This was 5 and 6. Now we're on the next page. Does anyone not have the notes from yesterday? Was anyone not here? Okay. So who needs it? Okay. Now the first part is kind of like what we just talked about, so if that kind of made sense, you know. I don't have a copy of the first page yet, but yeah, maybe tomorrow I'll have a copy of the whole notes, and you can just look at the first page. All right, so everyone has the notes sheet. Were you here yesterday? Oh yeah, you were. Oh, because you missed the final. That's why, right? All right. Well, anyways, did that make some sense? What we were just doing? Okay. All right. So we're about to take notes. You know what that means, right? Please do not have headphones in your ears. That'd be nice and cool and everything, right? All right. So, next thing we're doing. Appreciate y'all. Y'all are all great. Great students. Now, we are on this part right here. Let's talk about multiplying. This can be kind of easy, okay? So here's what you need to know about multiplying radicals. Ready? Outside multiplies with the outside. Inside multiplies with the inside. That's it. So let's do that. On these two radicals that are being multiplied, what's on the outside and the outside? 2 and 6 are multiplying to make 12. And then, on the inside, square root of 3 and square root of 2, those multiply. 3 times 2, 6. Easy? Now, the only thing you might have to do is reduce the radical, if you can. Now, does 6 reduce? That's the question. So let's try it. 6 is what times what? 2 times 3. That's it, right? So if there's no pairs, it doesn't change, right? So the answer is actually just 12 square root of 6. You want to try to break it down, but if you can't, you just leave it like it was, right? Cool. Now, the next example, what do I multiply again? Outside. 3 times 4 is? All right. And then the insides, 6 times 2 is? 12. I should try to reduce that radical. Square root of 12, so let's break it down. 2 goes into it, 2 times 6, and then 2 times 3, right? Sure? Six is even. That's 2 times 3. Now, do I have any pairs? I do. So this actually has to change. It has to reduce. So a pair of 2, and what's outside already is 12. So the 12 and the 2 will multiply to make what? 12 times 2 is 24, and my loner is 3. 24 squared root of 3. Okay. You try the next two on your own. I'll give you a couple minutes. You try it. So, what do we get here? What did y'all get for number 1? 12 what? Square root of what? Is that it? It is not. So we want to try to break it down, right? Does 25 break down? What is the square root of 25 off the top of your head? 5, right? So it's really 12 times 5. Okay? Or if you want to do the factor tree, you would do 5 times 5. And then you would have the outside 12 times that 5. Either way, you get 12 times 5, which is 60. Okay? So you don't want to just have a square root that's unreduced. Okay? On the next one, what'd you get? Fourth square root of 6 is good. Okay? Now, here's something new, but it's something old, kind of. Okay? When you multiply a radical times itself, the radical goes away. Okay? So check it out. Square root of 2 times the square root of 2, remove the square root, is 2. So here's why. Square root of 2 times square root of 2 is really square root of 4. And what's the square root of 4? 2. So I'm not telling you you have to do this whole process every time. But I'm telling you, you can do the shortcut. If you see a square root times the exact same square root, it removes the square root sign. Just that number. So over here, square root of 12 times square root of 12, remove the square root, it's going to be what? 12. Because it's the square root of 144, and the square root of 144 is 12. Okay? So this one's pretty straightforward. I'll give you a minute. You can do it. Do those two. Takes less than a minute. Takes 2 seconds. Right. So square root of 3 times square root of 3 is what? Very good. Square root of 37 times square root of 37 is 37. This stuff should be easy. The thing you just have to do is remember it. Otherwise, you might end up doing this whole step, which is not terrible, but again, square root times itself removes the square root sign. That's what we know. And let's take that to the next page. We should be able to now divide radicals. So we multiplied radicals. Outside times outside, inside times inside. Same thing for dividing. Outside divided by the outside, inside divided by the inside. Okay? So outside, 4 divided by 2 is what? 2. And then square root of 15 divided by square root of 3. 15 divided by 3 is 5. That's it. Just divide the outsides, then divide the insides. So on the next one, 6 over 2 is what? 3. 10 over 5 is 2. Now, you would want to think about, can I reduce that? But 5 is prime over here, 2 is prime over here. So, all right, so I'll give you a minute or two. Try these. Okay, sorry. So 5 and 6. Who that? You with me? You awake? On number 5. Now, there's an 8 and there's nothing on the bottom. You could think that's a 1, but it's 8. 4 over 2 is what? 2. 2 is prime. That's it. So, on number 6, 2 over 2 is 1. Now, usually you don't write the 1 in front of a square root sign. It's implied. You can, but, and then 4 over 2 is what? 2. So it's either 1 square root of 2, which is okay, but usually it's just square root of 2. That's how you'll see it. Cool? All right, now we're about to do the most important thing that we're doing today, because this can be confusing. For a lot of people, they don't like this, and I'm trying to make this as easy as I can. The best way to do it is to pay 100% attention. Give me like 5 minutes of your time. Stop. Okay? I want your heads up. I really want your heads up. I really can't afford to teach this to 30 people individually. So let's talk about this all together. All right, ready? There are a few things in math that are not allowed, right? I know you like to do things that are not allowed, right? Like be late to class, right? Now here's something that's not allowed. Square roots on the bottom. Okay, you can't divide by a number that's a decimal. It doesn't divide evenly. Someone's at the door, that is true. Well, anyways, so you cannot have a square root on the bottom. Cool? That's a math no. So how do you get rid of the square root on the bottom? Now, we learned we learned minutes ago, how do you get rid of a square root? You multiply by the same exact square root. That'll remove it, right? So we know that. So, over here, on this example 7, if I want to get rid of the square root sign on that 3 on the bottom, I'm going to multiply by the exact same square root. So is everyone hearing me? I'm not believing it when your heads are down and you're doodling. Can you please pay attention? Please. Please. To get rid of a square root on the bottom, you multiply by the same square root. So here's how you're going to write it. Is everyone writing with me? Times the square root of what? 3. And if I do it on the bottom of a fraction, I have to do it on the top to make it stay equal. Okay? So, on the top, 2 times the square root of 3. What do you think the 2 times the square root of 3 is? Not 6. It's not square root of 6. You have a regular number and you have a square root. Those are not the same, right? So when they're not the same, you just stick them next to each other. So 2 times square root of 3 is 2 square root of 3. Cool? So 2 square root of 3 over, and now, square root of 3 times square root of 3, we just learned this. Square root times itself removes the square root sign. What's it going to be? 3. So it's the square root of 9, which is 3, right? So again, the reason why we do this is just to remove the square root sign. So you don't actually have to multiply them and then reduce it. Just cut to the chase. 3. Okay? Has everyone understood those steps so far? To get rid of a square root, you multiply by the same square root on the bottom and the top. Now, 2 over 3, does that reduce? No. Square root of 3, that doesn't reduce. So that's it. Okay? It's an ugly fraction, but the bottom has a whole number. That's what you want. Okay? All right. I want to do the first one with you on number 7. So, on number 7, I got a square root on the bottom. How do I get rid of the square root of 2? Times the same square root. So times what? Square root of 2 on the bottom and on the top. So on the top, 8 times the square root of 2. Regular number and a square root. Stick them next to each other, right? So 8 times square root of 2 is 8 square root of 2 over square root of 2 times square root of 2 is 2. Right? Now, unlike the last time, this one I could actually reduce. Does everyone see that 8 and that 2? That can reduce. What's 8 divided by 2? So this is really 4, and then the square root of 2 still goes next to it. That's it. Okay? Let's try these other ones. So to get rid of that square root of 3 on the bottom, it's times the square root of 3. times the square root of 3. Is everyone getting that idea? Multiply by the same square root. So on top, 9 times the square root of 3 is 9 square root of 3. And on the bottom, square root of 3 times the square root of 3 is what? What do you think? Square root times itself just removes the square root, so it should just be 3. Does the 9 over 3 reduce to what? Not 2. Okay, so 3 square root of 3. That's it for that one. What am I multiplying by on this one? Okay. Square root of 2 on the bottom and on the top. So on the top, 7 times the square root of 2 is 7 square root of 2. On the bottom, square root of 2 times itself removes the square root. It's going to be what? Just 2. Can I reduce 7 over 2? No. So just leave it as 7 square root of 2 over 2. And then last but not least, square root of 3, square root of 3. 8 times the square root of 3 is, okay, 8 square root of 3. On the bottom, square root of 3 times square root of 3 removes the square root. It's just 3. And we can't reduce 8 over 3, okay? So, that's how you should be able to reduce a radical. Not reduce it, but that's how you should be able to, it's called rationalize the denominator. Get rid of the square root on the bottom, okay? Now, flip it over. There's one last thing you got to know is adding and subtracting radicals. So let's do that real quick. Now, hopefully you remember, when we have x's and y's, variables, you can only add the like terms, right? So 2x and 3x gives you 5x. 7x minus 5x is 2x. But look at letter C. Can I add 5x and 3y? Different things. So when they're not the same, you just write them next to each other. Okay, these two are different. Okay? So, let's add square roots. The same way we add variables. 2 square root of 3, 5 square root of 3, 2 plus 5 is what? 7, and the square root is going to stay the same. Please do not add the square roots. You're only adding the coefficients. You're only subtracting the coefficients out front, okay? So what if there's no number? Put a 1 there. 4 plus 1, 5, and the square root is still 3. Same goes for subtraction. So 5 minus 3 is 2. Square root stays 7. 2 minus 1. Square root stays the same, but usually you just see it as square root of 3. Okay? So I want y'all to try these real quick. Be careful with number 4 and number 5 because they have terms that are not like terms. Okay? So careful with 4 and 5. Give that a shot. All right. What'd y'all get for 1? 6 square root of 3. Number 2. 4 square root of 5. Number 3. 2 square root of 2. Now 4 is tricky. Does everyone see there's a different square root and a different square root? Just like when there's x's and y's. You can't combine them if they're different. So is everyone looking? 3 square root of 7 plus 2 square root of 5. Just rewrite it. Can't do anything with that. Don't put 5 square root of 12. You can't do that. You can't add the square root signs. Okay? Okay. We're going to finish these off in these last 2 minutes. I know the train's going off, but let's finish writing these down real quick. On 5, I can only combine these two because they have the same square root sign. 2 minus 3 is actually negative 1 square root of 3. And then I bring down minus square root of 5 next to it. 8 minus 7 is 1 square root of 2, or just square root of 2. And these last 4 we'll do real quick. 3 plus 4 is 7. 7 minus 8 is negative 1 square root of 2. 5 square root of 5. Okay. And then these next 2 we might try to work into the warm-up tomorrow. So we'll finish these next time because I want to have more time. All right?